In this video, we're going to do another sample problem where we have to find the Ka or Kb of a substance. In this case here, we're going to find the Kb of a weak base given some information. So we don't have the formula of the weak base. We're just told it's a generic weak base. And that's okay. It looks kind of scary when you don't have a formula, but we can just make up a letter. We'll call it B for base. And so when you have a weak base and it's reacting with water, we know the base is going to accept the proton. And so since it's weak, we have our double arrow, and we're going to have BH. It accepted a proton, but plus because the proton is positive. And since the water gave away an H, it's now going to be OH minus AQ. Now, we want to find the Kb, so we know we need to make an ice table, and we're going to have to eventually make a Kb expression. We don't care about keeping track of water because it's a liquid, but we do know our initial concentration is 0.1 molar. And our change would be minus x, 0.1 minus x. We start off with 0 here, plus x based on the molar coefficients, plus x here over here, and then x and x. And so we have to make a Kb expression. We know that Kb, because we're dealing with a weak base, is going to be OH minus times the BH plus over B. And if we replace that by x's, it's x times x over the 0.1 minus x, which is x squared over 0.1 minus x, which gives us our Kb value. Now, we need to find that x value. Notice that we have the pH. The pH won't really give us anything too useful directly, but indirectly it does. Remember that we have OH over here. The pH is derived from the H3O plus. We don't have H3O plus. But is there a way we can somehow get OH from pH? Well, as you know, there is. There's this great relationship. The pH plus the POH gives you 14. So what that means is if you want the POH, you just have to do 14 minus pH, which is 14 minus 11.8, and you'll get 2.2 as a POH. And now you can connect that directly to the concentration of OH, because you know the concentration of OH is going to be 10 to the power of negative POH, which is 10 to the negative 2.2. And that's your x value. Don't forget this isn't molar, mole per liter, because it's a concentration. So we just found our x value. This is 10 to the negative 2.2, 10 to the negative 2.2, 0.1 minus 10 to the negative 2.2. So we can now go and plug that x value into our Kb expression. Kb, remember, was x squared over 0.1 minus x, which is 10 to the power of negative 2.2 squared over 0.1 minus 10 to the power of negative 2.2. And we'll get 10 to the negative 2.2. Oops. Don't forget to square it. Divided by 0.1 minus 10 to the power of negative 2.2. And we get 0.000424917, or to 1 sig fig, because of the 0.1 there, 1 sig fig would be 0.0004. So Kb is approximately 0.0004. Or you could say 4 times 10 to the power of negative 1, 2, 3, 4. And this is our Kb value for this weak base. And so what we did is we made an ice table for the weak base. We used our information for the initial concentration to fill out the ice table. We made a Kb expression, as you can see over here, and we replaced it all by the x values there. We had to find the x value, which we could find by using the pH, by converting that to a POH first, and then that POH could be converted to the concentration of OH minus, which is in our ice table as our x value. And so once we have our x value, then we can go and plug it into our Kb expression over here, and we get our Kb as we see over here.